All right, 10-3, I'm going to refresh your memory a bit because I know we had spring break in between 10-2 and 10-3. So what we were talking about in 10-1 and 10-2 was circles, okay? We talked about pi. We talked about circumference. Circumference is the distance around a circle. Anybody remember that formula? Circumference equals 2 pi r or pi d, same thing, right? What else did we talk about? We talked about arcs and chords and stuff like that, okay? So on 10-3, we're talking about arcs and chords again. So we're going to have a few new theorems. So arc of a chord, when a minor arc and a chord share endpoints. So if you look, this isn't, I mean, this doesn't really tell you anything. It's just explaining a picture, I suppose. But we have arc AB and we have chord AB. So that's an arc of a chord. Okay, and then we're going to use that for the next couple theorems, I think. 10-2, in a circle, or congruent circles, two minor arcs. What's a minor arc again? Less than 180, right? Two minor arcs are congruent if and only if their corresponding chords are congruent. So for example, if I were to take this picture and add a CD to it, okay? So these are both minor arcs because they're less than 180, all right? If their chords are congruent, if I say CD is congruent to AB, then the arcs are congruent. Arc AB is going to be the same as arc CD. That's a picture for what we just said. Did I lose anybody? Okay. Theorem 10-3, if a diameter or radius, because if you think about it, obviously this is a diameter, but if I were to extend the radius, it would be the diameter. So for this picture, either one, it doesn't matter. If a diameter of a circle is perpendicular to a chord, so diameter perpendicular to a chord, that's what we have here. Then it bisects the chord and its arc. So it bisects this chord into two congruent pieces, and it bisects this arc into two congruent pieces. Is that okay? Theorem 10-4, in the same circle or congruent circles, two chords are congruent if and only if they're equidistant from the center. So I'm going to draw that. Here's the center, okay? Here's a chord, here's a chord. All right, so I guess AB and CD, it doesn't matter. So if they're both equidistant from the center, what that means is the distance from a point to a line is always a perpendicular. So this has to be a perpendicular, and these have to be the same. So if this piece is congruent to this piece, then AB, whoa, B, maybe, is congruent to CD. That's a picture for what they said. Do you guys see how I drew that? So we have this chord and this chord are equally spaced from the center, so therefore they're the same. AB and CD are the same. That's it for the notes. Have I lost anybody anywhere? Okay. Number 9, find the value of x. How many degrees are in a circle? 360. How many am I already using? 106. So what's 360 minus 106? You're going to need your calculator at some point, so you can just get it out now if you'd like. But what is 360 minus 106? 254. So that means is this much is 254. What I just learned is that if two chords are the same, so LM and MP are the same, then their arcs are the same. So if this is x, then so is this, right? So what am I going to do with that 254 to find the x? Divided by 2, you end up with 127. X is 127. Is that all they wanted? Okay. So on your homework, I don't need this. You're welcome to show me that. You can get a drink if you want. You're welcome to show me that, but I don't need it. So on something like this, I know how easy it is to just take 360 minus 106 in your calculator, hit divide by 2, be done. But on notes, I'm trying to show you guys this kind of stuff because at the end of the chapter, you may forget how we got that. Does that make sense? So I won't think you're cheating if you just had a 127 there. That's fine. Okay? All right, number 11, find the value of x. If this arc, MN, is congruent to PQ, then what do we know about their chords? They're the same. So MN chord MN, or line segment MN, is congruent to PQ. So this is where a lot of you guys that are more algebraically minded really like this chapter because it's really a lot of algebra with just a few pictures, right? So 3x plus 25 equals 26. You're going to subtract the, did I say plus 25? Sorry. 3x plus 5 equals 26. Subtract the 5 and you get 21. So x is that what they wanted? Yes, x is 7. Let's say they wanted PQ. technically you'd have to plug it back in, or you could have just looked at it at the beginning and been like, well, if that's 26, then this is 26. But they asked for x. Did I lose anybody? Okay. In circle A, the radius is 14 and CD is 22. Find EB to the nearest hundredth. Okay. So I don't want you to assume this all the time, but if they say find EB to the nearest hundredth, then you get a pretty number, a whole number, or yeah, a whole number, or natural number, either way. It's kind of your hint that maybe you did something wrong. If they say round to the nearest hundredth, you're probably supposed to round. Does that make sense? If we get like 4, I don't want to say you're wrong, but it's kind of a hint that maybe you're wrong. Okay? So on this one, let's go ahead and label what we know. We know that CD is 22. So if you go back to one of our theorems, I can't remember which one, do you see how this is a radius perpendicular to a chord? Right? So which theorem is that? Is that 10.3? Yeah, 10.3. So what that means is if the whole thing is 22, then what's just CE? 11. And what's ED? 11. They're the same, right? These are the same. Is that okay? I know that the radius, for example, AB is 14. But if I put this whole thing as 14, right now that doesn't really help me that much. It's true, but it doesn't help me that much. It's not like EB is 7. It doesn't work that way. Do you guys get that? Okay, so I'm going to have to find it some other way. You can draw a radius anywhere, right? So just because I see AB doesn't mean that's the one I have to use. Isn't this also a radius? From the center of the circle to the outside of it, well, to the circle itself. So isn't this also 14? How did that help me? Yeah, you have a right triangle. What do we know about right triangles and their sides? I can use Pythagorean Theorem. So I'm going to say AE squared plus the 11 squared equals the 14 squared. We don't want to round to the end, okay? So in your calculator, you would take 14 squared minus 11 squared, and what do you get? Yeah, so AE is the square root of 75. Some of your calculators may give you, that would be 5 root 3. That's fine too, but let's not round yet. Does that make sense? So AE, this piece here, is the same as the square root of 75. Yeah. Because that's not the question, they didn't ask us to simplify. I don't do extra math unless I absolutely have to. So because the question is actually the length of this piece and they told me to round, I'm not going to simplify a square root. You can, but I wouldn't do it. It's extra work. Okay? So if I know that the whole thing is 14, right, then AE, or excuse me, what do we want? EB? Sorry. Then EB is going to be the same as 14 minus this piece. What did we say this piece was? Square root of 75, right? The whole thing, 14, minus this piece of it, the square root of 75, leaves me with the EB, which is what they wanted in the first place. So now you can round. Nearest hundredth is 2 decimals. 5.34. EB is about 5.34. Uh-huh. I knew the radius, this is the radius again, is 14. And I knew we just found this was root 75, bless you, and this is what they wanted. So I took 14 minus this piece, and what you're left with is what they wanted. Does that make sense? Okay. So again, that radius, you could draw a radius anywhere, but these other places aren't really helpful. I could have drawn it over here as well. I could have done the right triangle on this side. Doesn't matter. I just did it on the right. Okay. Last one. In circle S, LM is 16 and PN is 4x. Find x. So if you look at this, this looks just like, I think the picture I drew for 10.4, right? These are equidistant from the center, perpendicular, right? So if these are equally spaced, then what do you know about the two chords, the ML and the NP? They're congruent. They're equal. So 16 equals 4x, therefore x is 4. Did I lose anybody? Super easy? Okay.